Welcome everybody to session AJ. We created a zOS based image to carry out our enterprise transformation. Pleased to have Troy Bishop here, and I think some of his colleagues are also on the call, so that's good. The chat area is where to ask questions, so if you have any questions, please type them in and I'll pass them on to Troy. Other than that, enjoy the session. Troy, I will go on to mute and stop my video, and you can crack on when you're ready.
Okay, thank you very much, Stuart. So good morning, good afternoon to everyone here. Hopefully not good evening, but if you're here in the evening, well, thanks for joining. My name is Troy Bishop. I'm the architect for a variety of IBM products that are all around creation and running zOS, real zOS in either an emulated or virtualized environment. So there's a few products, and I'll mention them briefly through the session here. But the primary purpose of this session is just to talk about how we go about creating a zOS image that can run on any of those environments to help transform your enterprise applications and sort of adopt the DevOps principles that are necessary for being able to quickly make changes to your application and push those out to your customers. Okay, so I'll just start off. Why do I need that? And that's really just what I was talking about. Is you've got different aspects of your application development process that have constraints, and it's usually around just getting access to systems. I want access to a zOS environment so that I can perform my development activities and not have to worry about someone else potentially mucking up the system. I want a zOS environment, and I want to be able to do tests, but I just don't have enough systems to be able to accommodate all the testing that needs to be done. Or even from an administrative perspective, I've got all these people asking me for more systems, and I just don't have enough bandwidth in me to be able to support all of them. There's many different from different perspectives. There's many different reasons why a lot of the folks in zOS dev test space are constrained. And again, it really just boils down to insufficient resource available for being able to do those activities. And just that's where it would it'll be nice to have the capability of being able to introduce the self-provisioning of either emulated or virtualized environments. And the primary use cases, of course, are being able to drive faster software development, being able to perform activities earlier than later, being able to perform testing earlier and resolve defects earlier so that you can produce the best quality software possible. There are a couple other use cases that are important as well, such as being able to integrate this process into your DevOps pipeline. So perhaps during your nightly build, you could also spin off an environment, have automated tests run against it, and then have that environment destroyed at the end of the day, and then everything goes on as normal. There's also a few other use cases, such as employee education. It's can be tricky to provide, as an example, a junior sysprog environment that's broken, and give them a place to play around to learn. You could very easily clone your systems that you have now. A more senior person could introduce problems into it and say, okay, junior sysprog, go correct those. So that's these are just some of the use cases where having these types of environments available, and available to not just the dev test space, but also to system programmers and stuff like that, for being able to play around with these environments. So then the next part is really just more on the product side of it, is where can I run these custom zOS images? And again, this is all just for dev test workload, not for production. So production, of course, for any of these products is not allowed from a licensing perspective. But so we've got a variety of different offerings, and I won't go into these too deep, but if you're certainly more interested in these, you could shoot me an email or ask in the chat here, and I can talk to them a bit more. There are 4 different offerings available right now that give you the capability of having a virtualized or emulated environment. The only one that I should say that the first 2 that I'm going to mention are emulated. They're both run on x86 hardware, and they give you real zOS, so it's your real zOS software, but running on an x86 machine. The first one is IBM Z Development and Test Environment, or ZD&T for short, and yeah, it's an offering that IBM provides, allows you to run real zOS on x86 hardware, and we provide tooling with this offering that allows you to extract your on-prem environment and have that running on x86 environments as well. The other one that's on x86 as well is WASI Sandbox. WASI Sandbox is exactly the same thing as ZD&T. It's just more focused on the OpenShift space. So it's a containerized version of ZD&T, and gives you the capability of running either a custom image or the same as ADCD. I didn't mention it previously, but with both of these offerings, we provide a package called ADCD, which is a pre-built by IBM zOS bundle. So you can either have ADCD or your custom image running in a container within the OpenShift platform. The next on-prem type of solution, and I should mention the first 2 are on-prem, are primarily on-prem as well. So I mean, but there's nothing saying they couldn't run in the cloud, just a little bit more work, but certainly could work there as well. The other offering that's provided by IBM that is primarily focused for our on-prem dev test environment provisioning is ZVDT. You can think of ZVDT as exactly the same thing as ZD&T, except that it runs on Z hardware. So it's going to run on a Linux S390X machine, and it gives you the capability of provisioning zOS environments on that machine. Now, the major difference between the 2 that I just mentioned, Sandbox and ZD&T, compared to ZVDT, is that because we're running on real Z hardware, we don't need to emulate the processing, so we can go directly to the physical processor of the Z machine, and as a result, performance is quite a bit better. So as you can imagine, on x86, if you've got to take Z instructions and convert it to x86, there's a bit of a performance penalty there, and then it's even worse. And then when you have Java on top of that, you're going to convert Java bytecode to Z and then Z to x86. So Java workloads on the emulated environments, both ZD&T and Sandbox, are relatively slow, whereas on ZVDT, when you're running on Z hardware, you don't suffer that same performance problem. So that's the main difference between the 2. And then finally, the solution that we have in the cloud space, if you wanted to have the capability of provisioning a zOS environment in IBM Cloud, is called IBM WASI as a Service. WASI as a Service, from a very simplistic perspective, can be thought of as ZVDT, but in the cloud. So it's running on real Z hardware. You're going to get a zOS that is virtualized using real Z resources, and gives you the capability of running zOS, in more of a pay-as-you-go type of model. So you're paying for your usage as opposed to having a permanent thing which is on-prem. So a lot of this really depends on your use case and your comfort with on-prem versus cloud. But this is the offering that would allow you to have zOS environments within a cloud environment. Okay, and finally, this is just I just put this in the chart deck more as a if you want to come back and review it at a later time. This is just a summary of all of the offerings and the capabilities that they provide. I didn't really want to go through everything here, so I'll just leave it there as more as a reference material. But just sort of reiterating, ZD&T and WASI Sandbox are x86 based solutions. They provide emulated Z hardware on that x86 hardware, and of course it runs your real zOS software and any real zOS software. ZVDT is the same as the 2 that I just mentioned, except that it runs on Z hardware. and of course doesn't suffer that performance problem of having to emulate the Z instructions on x86 processor that the previous two do. And then WASI as a service is the IBM Cloud offering for being able to have zOS environments provisioned in a more of as a pay-as-you-go type of model within IBM Cloud. Of course, with WASI as a service where it's in cloud, you don't have to deal with the physical resource aspect of it. You just go in and say, I want a zOS environment, and you'll get one. Whereas with the other ones, you have to deal with the physical hardware, whether it be your on-prem Linux on Z environments or x86 environments. And the last thing, again, more just as reference material for anyone that is interested in this, there is a link, and I have it at the very bottom of this slide here. There is a link to the zOS knowledge page that talks about how zOS, for lack of a better term, how zOS sees these environments. So if you're building zOS software and it matters where it's running, whether it's on ZVDT or ZBNT or any of the other virtualized mechanisms, there is a way that you can programmatically check based off of these CVT bits. ZVT, sorry, I get the acronyms all mixed up. CVT bits, and yeah, you can figure out the environment that it's being run in. Okay, so that was more just introductory content that I wanted to bring up just to sort of set the tone for why you need a custom image and where that can be run. So now I'm just going to get a bit more into the weeds in terms of how you go about building these images, what tooling is available for that, and some of the real life use cases that we have for what real customers have gone through with and some of the pains and some of the solutions that we have in place for building these images. Okay, so we have tooling with all of these IBM offerings. So there's specific tooling for ZDNT, there's specific tooling for Sandbox, ZBDT, and WASI as a service. The one I will mention, the one for WASI as a service is called WASI Image Builder. So if you've heard that term, that's the tooling specifically for WASI as a service. And the intention for all of these tooling is to provide a simplified way of being able to extract your on-premise environment and be able to put it together as an image and then have that image run on any of those offerings. So the image that we produce is, for the most part, portable between all of the offerings. There is some limitations with the WASI as a service offering. That's certainly something that we're working on, and I'll get into that in a little bit as we look into some of the challenges that we faced. But excuse me, but yeah, the tooling is really meant to be a sort of a single place to go to where you can go about creating this content and then either provisioning it to on-prem resources, whether that's provisioning to ZDNT or ZVDT or Sandbox, or deploying that image to IBM Cloud, and then IBM Cloud takes care of the provisioning process. The way that we started to look at how we could go about doing this, and taking something that could be extremely monolithic, as all the data that exists on your Z machine, is we started promoting the idea of let's see if we can get people to break down that data into smaller chunks. It's really hard to deal with one massive thing and and have that brought over to another environment. First of all, there's if there's a lot of data there, it's going to take a lot of time to transfer that around. If and potentially even worse if you're going to something like IBM Cloud, where you have to send that content over the public internet. So the idea was like, let's promote the idea of having smaller chunks of this data, and we represent that as components within the tooling. So a component is really meant to be a set of artifacts, zOS artifacts, that is sort of logically grouped together, depending entirely how you see fit. And and then along with that component, besides the artifact side, there could be some metadata as well. So, you know, in the case of, let's say, a zOS component that's really your system volumes, there will be a bunch of metadata that comes along so that we know where, you know, the TCP/IP profile is. We know where all the other types of metadata that we need. We know the devices that were allocated to the system so that we can replicate that on another system. So yeah, we have today we have within ZD&T, we have the concept of 4 different component types, ZD&T and ZVDT. Those 4 are volumes. So you could have a component that is a set of volumes. You could have a component that's a set of data sets. You could have a component that represents your KIX transaction, or you could have a component that represents a set of DB2 tables. So the idea was that we could you know, sort of segregate that together and then as separate artifacts, and then when it came time to putting it all together as an image, you could pick and choose what components make sense for your particular image. So an image really represents everything that is going to be running on the either emulated or virtualized environment. So you've got your zOS component, that contains all your system volumes. You've got your DB2 volumes. You've got your KIX volumes, and then you have the data that kind of goes along with that. You could have data sets that represent your application and so on. So the idea was to be able to take smaller, you know, let's take your massive system and try to make smaller parts out of that, and then once you have those smaller parts, then you can take those smaller parts and merge them together to a deployable package, which we represent as an image, and that basically becomes what you would have running on any of these systems. Now with this, there is also I mentioned before the ADCD package. So we do have support for being able to take, and this really comes down to use case as well, depending on what you're looking for. We do have support where you can extract certain aspects of your on-prem LPAR, whether it's DB2 data or KIX data or data sets, and have those represented as a component, and then you can merge that into the ADCD bundle that IBM provides with these offerings. So if and this is purely, again, use case scenario, if you're running zOS 2.3 and you want to see how everything works with a newer version of zOS, then that might be a good place to play around with that. You could extract your application, merge it into the IBM ADCD that's provided, which is packaging 2.5 right now, and then you could then you could provision that to any of the environments that were mentioned and be able to run those types of applications there, just as a way of you know, sort of testing how everything's going to work in a different zOS environment. So yeah, within the tooling, again, we have the concept of a component, an image. An image is really just a package of everything, and that image could be everything that's coming from your on-prem LPAR, or it could be a combination of data that came from your on-prem LPAR and then packaged with the ADCD bundle. Okay, and then finally, the last part from the tooling perspective is, you know, once you've got your image together, and I should mention that there is some capability of being able to modify some of the image properties. So you know, there's various aspects of an image that could be changed, networking, things like that. That all can be done within the tooling as well. And then once your image is produced, then from the tooling, you have the capability of either provisioning it to any of the target environments that I mentioned, excluding WASI as a service. So you could provision it on an on-prem ZD&T environment, provision it to an on-prem OpenShift environment, or an on-prem Linux S390X machine, so ZVDT. Or you have the capability of deploying that image to to IBM Cloud for use within WASI as a service. So the idea from the tooling is from a WASI as a service perspective is really to get that image into IBM Cloud, and IBM Cloud makes use of somewhat of a different methodology when it comes to provisioning. So the image that exists within the tooling is going to then be converted to what's called a custom image within an area called the VPC, Virtual Private Cloud area of IBM Cloud. And once you have your custom image there, then you can basically do the same thing as you go in and say, yeah, I want to be able to provision an instance from this image and make it happen. So the actual act of provisioning your zOS environment when it's within IBM Cloud is done through IBM Cloud. When it's on-prem, it would be done through the tooling that we provide for the different offerings. Okay, I should maybe pause here for just a second just to see if anyone has any questions before I move on to the next part. If not, then I will continue on.
No questions at the moment, Troy, but if people want to put them in through the chat, please feel free. It's quite an interesting topic. So Troy's here, make use of it.
Okay, then I will continue on, and like Stuart mentioned at the beginning, if you have any questions, certainly feel free to interrupt me at any time. Okay, so what I'm going to go through now is just some of the challenges we face with creating a portable image that can be that can then be brought to any of these types of environments. I'm sure if you're in the system administrative space, you can probably already come up with a few. And probably more that are going to be mentioned here. So I'll just start with the first challenge, and it's really over. It's really kind of what I was just talking about, which is how do I bring over just the subset of my dev test LPAR? Ideally, you don't want to bring the whole thing, and that's where we really wanted to promote the idea of the tooling, and just, sort of trying to promote the idea of segregating different aspects of it into components, or the other term that's used I've heard it in a few shops is just the idea of Lego blocks. You kind of want to build up the different parts of your LPAR, whether you have a component that represents the system content, a component that represents your load modules and libraries and things like that, another component that perhaps represents some of your middleware content, and this is where things get. This will lead into another topic is your application data. Application data is usually very large and causes other problems as a result of bringing it along, but we'll get into that one later. And really the idea for promoting this idea of separating the different logical parts of your machine is so that if you have to come along and refresh parts, perhaps you just want to refresh your load modules, perhaps you just want to refresh your system, perhaps you just want to refresh your data, then it becomes a lot easier to manage that. You can and this is where we're working towards with our tooling, is you can go in and say, yeah, I just want to refresh the data part. So make that happen. And then that becomes a lot easier from the management perspective of being able to, either, I mean, this is purely, again, it's a work in progress, but you could just take the volume offline that contains that data, replace it with the new one, and then vary it back online. Something like that. So a lot of these types of actions can be automated. It's just a matter of the user saying, yeah, I want to refresh my data, and make it happen. So if things are broken down in a smaller manner, it becomes a lot easier to make that happen. And that's where we're really trying to promote the idea of utilizing the components within the tooling, just to make that easier to happen. The other aspect of it is and I'm going to point specifically to the cloud offering that we have. So with WASI as a service, again, everything within the VPC space is based off of the custom image idea. Well, a custom image is really everything. It's everything that you want to be running. So if you wanted to replace just parts of that, it becomes very difficult unless we have a way to say, yeah, just just replace one or two volumes that are part of it, and that goes back to the idea of a component. So the thought is right now that if we can set things up properly within IBM Cloud, the custom image really is just a pointer to a block of data, but the tooling also has better understanding of those blocks of data and can then replace parts of it. So the way that it kind of works today, and it's certainly not ideal, but the way that it kind of works today is, unfortunately, if you wanted to replace parts of it, you've got to upload that entire thing again. So that's where we need to be able to have within our tooling a way of separating that content, so we can just say, yeah, just replace this part, but leave everything else untouched. So that's certainly something that we're looking into and seeing if we can make happen. It shouldn't be a problem. It's just a matter of ensuring that the right actions happen. Like I said before, it just could be something as simple as taking a volume offline, replacing the file that represents that volume, and then varying it back online. But a lot of this comes back to you sort of following good practice in terms of segregating this data so that can be possible. If you had just one component that represents everything, then that would be a little tricky to do. Excuse me. Okay, so that's really the first one is really just trying to promote the idea of using the tooling to help break things apart. And then the next part is okay, so I've got this massive system, and this is an example below of again, it's a real customer scenario, so these are real numbers. It's not something that we had on-prem or anything like that. But I've got this real system, and it's massive. It's been around for a very long time. How can I figure out, so I sort of buy into this idea of separating things, but how can I figure out, just let's start with the minimum stuff. I need to start with the basic stuff of what do I need to bring over so that my system at least will IPL. Today, that the answer is, well, you're going to have to ask the system programmer, and the system programmer is going to have to manually select those volumes and hope he or she gets it right. And if they don't, then go back and try again until it is correct. Certainly not an ideal scenario, but that is the way it is today. What we're working on, and hopefully that's something that's available relatively soon, but what we're working on is a way to automatically detect those critical volumes that are needed based off of a set of the required data sets that are needed for being able to bring up zOS. So things like the LPA and linked list APF authorized data sets, the USS data sets, and so on. So making sure that we collect the information about the system and try to understand what the system looks like, and then being able to figure out which volumes contain these critical data sets, so that we can say, okay, at a minimum, here's the set, programmatically at a minimum, here's the set of the volumes that you need without any real human intervention. Now, this list may not be perfect, so we certainly give you the capability of saying, no, I really don't want this one, or yes, I want to also add in another one as well, or whatever the set might be. But this is sort of where we're working towards in terms of trying to make it easier for you to bring over at least your system aspect. Now, what I've got in the bottom left-hand corner is an example from a real client who had exactly this problem. They have a very, very, very large machine, as you can see here. There's many terabytes of data, many volumes, and they basically said, like, look, we've got a lot. We have no idea. Well, we have a good idea of what's needed, but we need some help to figure out, what the minimum content is that we need to bring over. Because if we bring over everything, we're looking at about 320 terabytes of data that has to be brought over, and in the x86 space, or places like that amount of data is not common. So how can we subset this data? And that's where we have this tooling that we're working towards that will help us figure out the minimum set. And in this case, we were able to reduce, from taking everything, which was, again, about 320 terabytes of data. We were able to reduce it quite a bit. So we took the approximately 7,000 volumes down to about 537 volumes, and saved quite a bit of disk space there with this particular aspect of it. Now, of course, a zOS environment isn't really helpful too much to a developer or tester without the application content, but you have to start somewhere, which is, this is the base that needs to be there. So if we could use this as the starting spot, then at least we know what the minimum is necessary to bring over to any of these emulated or virtualized environments. The next part is actually networking, and this is sort of tied into the previous one, the system volume. So on your zOS environments, you have your networking set up, and it works just great on the physical LPower machine, on the real machine. But for us to be able to bring that over to either an emulated or virtualized environment, there is some work that needs to be done to make it work. And networking is usually the biggest challenge that we have. So usually it comes down to how do we locate the IP address and replace it with a different one, because that static machine is now going to be cloned and then replicated many times, and each one is going to have its own IP address. Within zOS, there's of course many different ways that could be configured, and that makes it problematic from a tooling perspective to be able to manipulate that. So, and the other aspect is we do have some requirements that the location of the networking profile has to actually be a PDS. If you're using any other type of data set, then we won't be able to manipulate it. That the reason for that is because we have specific tooling that will allow us to extract PDSs from a volume and then manipulate it and then restore it back in. So what we're actually looking to do, and this is again something that will probably come relatively soon, is introduce tooling that will create a prescriptive TCP/IP configuration. So something that is well defined by us, static, and be easily manipulatable by our tooling. The idea is that you can either run this tooling and it will create a new load suffix with some data sets and content in there, and then that content will get merged in with your existing configuration, or not merged in, but sort of appended on to the existing configuration. So the idea is that we're not changing your system, we're just adding in another load parm that would be used in the emulated or virtualized environments. And what we will do in this case actually is rely on the IP address being in the symbols, so the IASIM member, and it becomes, we will make sure it's PDS, and we will make sure that everything is laid out properly for us to be able to go in and easily manipulate that. So we'll be able to go in and change the IP address and the default route, just so that we can ensure that networking will always work. Of course, this isn't going to be required because there's always hesitation towards tooling changing configuration. I can understand that. So we'll lay out all of this in documentation to ensure that if you want to do it manually, that's certainly fine as well. But the idea is really just to have everything laid out in the symbols, and for us to be able to just go in and replace the symbol with the symbol value with the new value, and in this case the IP address. So when it's cloned and brought over many different and provisioned many different times, we can just very easily change that with minimal work. So those are the two biggest things from a system perspective. Again, number one was the how do I figure out what the minimum content is? Number two is really the networking aspect. I've got my minimum content, I've got everything there. but how can I ensure that when that system is cloned and then provisioned n number of times, that each instance is going to have its own unique IP address and it will work, successfully. And a lot of this is necessary purely just because zOS doesn't have a DHCP client. If it did, that might be a little little easier, but where it doesn't, we have to manually modify a lot of the configuration in a way that where we basically inject an IP address into the zOS setup. And in order to do that, it needs to be in a somewhat standard format. Okay, so that's the system content, and then we start getting into the application and data challenges a bit. So on the application side, what we are working towards, and what we have and what we're still working towards is integration with other IBM products that allow discovery of that content. So there's an IBM product called IBM Application Discovery and Delivery Intelligence, or ADDI. And with the ADDI bundle comes a function called Application Discovery. And Application Discovery will analyze your application content. And we provide integration with that application discovery functionality. And what we get in return from it. So application discovery has a RESTful interface for being able to introspect all of the content that it has discovered of your application. And we can then, from a tooling perspective, we can then query that content and say, okay, we know you want to extract this application based off of a specific project name. So we want to extract this application. Here is all of the content that application discovery says you need. So here is, the list of all the data sets and things like that need to be extracted. So so this is possible today with ZDNT, ZVDT, and WASI Sandbox, in being able to build that data set component that represents your application. The reason I did not mention WASI as a service, and this is still, this is the future aspect of it, is because the content that is extracted for pushing to WASI as a service can only be volumes right now. We certainly want to have support for everything else, because you want to have as fine a grain of image as possible. But yes, today this integration is only possible with ZDNT, ZVDT, and WASI Sandbox. And we certainly hope to have the support for WASI as a service if you want a cloud type of solution for your zOS environments, for being able to build an image that contains that. So this is really our way of trying to say, like, let's have again a small component that represents your application, and it can be sometimes challenging because applications grow, they get large. It can sometimes be challenging to know all of the artifacts that are necessary. Of course, you can still go in and manually select whatever you want. That's certainly feasible. But if you, I think in a more realistic scenario, and certainly what we've seen with clients is, applications have grown over time. They've gotten really large, and it's hard to know everything that's necessary for an application to be extracted and brought over to another environment. So one way of solving that is to make use of a product like Application Discovery, which would then have a very large knowledge base of everything that's needed for that application. We can query that information, extract it, and then push it over to any of the environments, with the exclusion of WASI as a service right now. But that will certainly come soon. Okay, and then the last challenge that I wanted to talk about was application data. So you've got your system is all there, you've got your application content is there, and in order to test your application, you really need some data. And this I will say is still an area that needs a lot of work. It's still it's an area that needs that needs a lot more thought and a lot more work. I can make recommendations, but that's about it. And really the recommendation is to not package data with an image, because data is generally extremely large. You've got lots of different scenarios that you need to worry about. And as a result, you've got a large database, you've got a large set of flat files, whatever it is that you're using for persistence of that data. And if you include it in the image, you're going to end up with some really large image cases. Back to challenge number one, where I was showing an example of a real client zOS environment. They had, about 320 terabytes of data. That's the whole system, of course, but a large chunk of that was test data. A very large chunk of that was test data. So, do you really want to bring all of that content over to your isolated dev test systems? And the answer is probably not. And you probably don't need all of that data for whatever use case your dev testers are using. They probably only need a subset of that. So why not start looking into utilizing a test data management system for building up this subset of sanitized data, rather than packaging everything with the image. So one, it saves on cost because you're going to have to deal with the storage cost of it. And two, it's going to reduce the time it takes to provision these environments so that you don't have to transfer all this data around. And then three, you're going to end up with a much leaner image and something that's easier to work with and bring up, hopefully faster brought up, provision times. And then you have what's only needed for that particular instance for that development and test activity. So that's really the recommendation. I understand, and I think a lot of us understand that is where we should aim towards. But the reality is that today most places still do package data with a lot of their image, and it's certainly not a good practice for the reasons I mentioned before. It just increases the image size quite a bit, it makes it harder to work with. But if you do, certainly try to keep it separate from the tooling perspective, so that if you get into a situation where you need to refresh that data, which is can happen quite often, then the tooling, once we add the support for it, and the tooling can just refresh those specific parts. So a use case could be, I've been given an instance, doesn't matter where, it could be on-prem or in the cloud, but I've been given a zOS instance and I've been asked to do a new feature for my product. So I start the development activity and I work through it, everything's great. I've been manipulating the data a little bit as I've been going along just to test how things work. And I've gotten to the end and everything's great, but I also want to see what happens with this data, the original data that I had, to ensure that I've taken care of any migration cases and things like that. So I've built up the system, it's got my changes, and I've also manipulated the data a bit, but I want to see how it works with the original data. And that's where we get into situations of being able to just refresh parts of the running instance, and that's where I think it's important from an image building perspective to kind of keep things separate as much as possible. I wouldn't recommend having one component that's all of your data, because that's one massive chunk of data that's going to have to move over. But if there's a way that you can segregate it to be smaller, that would certainly be a better approach. Then, in that scenario that I was just describing, where the developer implemented a new feature, they could just go in and refresh parts of the data and, not have to worry about dealing with any of the system administrative stuff. That's really the intention of the tooling. The tooling will try to automate all of that kind of work. And they just say, yeah, I've tested my stuff, it worked great. Now I just want to see what it looks like with the original data set to validate that, when this feature gets merged in, it's not going to break anything with the existing data that I've got already on the system. So yeah, that's really the topic when it comes to data, is really just to try to, there's certainly recommendations, and if you can utilize a test data management system, have it generate and curate the data that you need for your situations. That way you don't have to bring over the, back to that first scenario, the 200 terabytes of data that you've got collected over the many years that your application has lived on its zOS environment. You try to avoid that as much as possible. But I also understand that that's that's a lot of work to get up and running. And if you can, if you have to package data in your image, then just try to keep it as small as possible, and hopefully make everyone's life easier when it comes to dealing with these environments, because updating that, the 200 terabytes of data again wouldn't be a pleasant exercise for anyone. Okay, so that's all I really had to discuss with regards to building zOS image. Again, the whole idea of this is having an image that can be easily cloned and then provisioned to any of the types of environments that we provide. So that's ZDNT, ZBDT, WASI Sandbox, or WASI as a service. WASI as a service being the one that's primarily targeting for in cloud. The other ones are for more on-prem type of systems. And again, the whole notion is to be able to get away from, I've got one system that is potentially constraining my developers or testers or admins from being able to try different things out. So being able to try to remove those hurdles and produce isolated environments for easier dev test and education type of activities. I hope this was beneficial. I certainly have a few minutes left for any questions that anyone may have. But if not, I thank you very much for attending, and certainly give your feedback on the session at the link that's mentioned here. So I'll just pause there, see if there's any questions from anyone.
Yeah, not at the moment, Troy, but I think you've made some really good points in there. Segregating data from the environment is something that I think culturally we're still struggling with on the mainframe.
Yep.
It's going to take a little bit of rethinking on how people can do that. But everything else was really interesting. Certainly is it ZVD and T now is the on mainframe one? That's a pretty interesting technology is just developing.
Yeah. So again, from a very simplistic perspective, it's ZDNT but on Z hardware.
Yeah.
And again, the benefit of that, of course, is we don't have to emulate the processor. We can use a physical one. Performance is much better. I should say with all of the offerings, we don't really. It's meant for early dev test activities. It's not meant for performance testing. It's not meant for production. It's not. There's a lot of situations it's really not meant for. But one of the biggest downfalls of ZDNT, of course, is if you used it, you brought over an environment and it runs some Java workload, like even zOS and Method, of course, out of the box with most zOS installs is Java based, and it's going to be slow, unfortunately, on x86 hardware just because of the amount of computation that has to happen. With ZVDT, that is not a problem because it's working off of the physical processor.
Yeah, the thing I like about it is that in mainframe organizations, I can often influence people that are involved in the mainframe platform, whether it's at HMC console level or somewhere else. Whereas when I've got to go into one of the distributed teams and get a server spun up or something, They always want to know what I'm trying to do, and then I start explaining it to them, and you lose them. So that's why I think the VDT is a great option, because it's keeping mainframe within the mainframe culture, not necessarily trying to keep it siloed, but people understand what you're trying to achieve. So that's the important thing. Okay, Rod Little has asked, any outlook on when tool to build images will be available?
So I guess we have tooling with ZDNT, ZVDT, and Sandbox that can be used for building images. And there's a separate tool for WASI as a service called WASI Image Builder. that can be used for building images. In terms of the other function that I mentioned in this session here, dealing with the detection of the system content and dealing with the networking, a lot of that will probably come. I don't want to give too much of a specific date, but it'll be sometime this year, probably first half, I would imagine, but we'll see. Certainly don't hold me hold my feet to the fire on that one, because that could change. But that's sort of the outlook, is we'll hopefully have that capability at the first half this year.
Okay, and Pete Wilson's got a question.
Yeah, hi Stuart. I'm just curious about, I missed the very first part of this, trying to find my way into the session, unfortunately, but I'm just curious about the sort of the application volume sort of cloning level, because that's sort of a major challenge when you're dealing with a sort of quantity of data that you are in that example. From our sort of past experience, was other tooling that was quite capable for that, like VCR, but you're still stuck with doing volume level sort of flash copies and things like that. So you, even with thin provisioned ASDI, you're probably still looking at a pretty substantial sort of investment, even though it'd probably get you there quicker. You're still having to make a pretty substantial investment.
Yeah, I mean, the simplest perspective is the simplest answer is, of course, exactly what you mentioned, which is, just take the volume. That's the simplest approach, but the downside, of course, to that is the sheer size of things.
Yeah,
and
it's kind of mitigated a bit now with the thin provision DASD. So even though you might be copying an entire volume, it might only be a few bits of it in reality that end up in the target.
Yep. Yeah. So what we're trying to look into a bit more on that space is well, that sort of feeds into the discussion I had a little bit earlier about the integration with application discovery. But if you wanted to take it from a manual perspective, it's more what data sets make up that application. Which I realize that can be a hard thing to answer, and that's where other tooling might be able to come into play to answer that question. But excuse me. But yeah, if you know what data sets make up the application and what KICS content makes up the application, what DB2 content makes up the application, then we can just extract only that content and then rebuild it on the target. So rather than extract volume A that's a few terabytes or a few whatever many gigabytes or something like that, and yeah, you only need parts of it, then we would know, okay, you want data sets X, Y, and Z, that those data sets are part of volume A, so we have that metadata collected. At provision time, we will then recreate volume A and then just restore those data sets. So on the target, you're still going to end up with the same sort of setup, but at least from the image perspective, the image is much smaller, which is important when it comes to moving that content around.
Yeah, but I guess that would be relying on sort of the network a lot more heavily.
Yes.
Right. Physical level sort of activity, with the flash copy or whatever in the controller.
Yeah, that's absolutely true. And one of the other things that we've wanted to explore for quite some time is, and this could be more of an important thing in the ZBDT space, is you've got a Linux system, and it's got access to lots of storage, no problem there. So why can't we just push the image once there and then rely on storage technology for cloning it, so that we don't have to transfer so much over the network like we do today, and not rely on the networking so much. But let's have that image live there. It's it's built in a way that you can just simply clone it in IPL, and then just rely on storage technology, like, for example, the one that we started looking into is BTRFS. But there's many other types of file systems that are available that allow easy cloning of storage, and like a flash copy type of situation. And then we just need to come along and attach it to the hypervisor and IPL.
Yeah.
That would certainly be better from a time perspective, and savings of networking transfer and all that kind of stuff.
Yeah. I would, you're still in the realms of potentially having to sanitize data as well, though.
Yes.
Post that. So yeah, I guess it doesn't matter in some sense. You might be able to eliminate a big chunk of time out of that part of the process, but there may be a substantial amount of work after that.
Yes.
And that requires duplication as well. At least for a period of time.
Yeah, absolutely. And yeah, I mean, so sanitization of data is just the handling of data is still a tricky part. And that's why I was saying in our data challenge, that's a really tricky problem that needs to be looked into and solved in a better way that we have today.
It's very difficult because general data is all mixed up, isn't it? You don't have it nicely segregated in the source where you can lift it as a single entity.
Yeah, that's right.
Wow, if only there were a tool on the market that could do a related data extract and obfuscation on the fly. Wow. But that's another vendor to talk about that. But yeah, Pete, there are solutions out there. I know that your organization is actually licensed for one of those, but it's the time it takes to look into it, isn't it? And that's
that's right.
That's the return on investment is, do you spend weeks understanding the data model and extracting just the data you need versus someone going to go, actually just take them 10 volumes over there or that pool or whatever. And that's what we see across the globe, is that understanding the data takes a lot of people versus let's just dump or flash copy all that stuff. And we just hope that we've captured what we need, the right sort codes or the right reference data or et cetera. So
yeah, that is a pretty intractable sort of problem, really. And
from a GSE perspective, Joe Winchester and myself are going to have a day in November in Whittlebury Hall focused on just that topic, because it seems to be the next big stumbling block. If we're going to virtualize test environments, make them short-lived for the early phases of testing, the data has to be right. You can't spend money on this stuff, because when you're actually looking at the WASI as a service, when you start seeing the cost generator on the right-hand side, it becomes a real thing, So it's going to be an interesting topic, and we'll see how that develops over the next February now, over the next 7 or 8 months. But yeah, we're going to be talking about it, Pete.
Yes. Yeah, it'll be a long day.
Well, maybe we start talking about it the night before in the bar, and then it'll be a lot more interesting.
You'll just have to record it because you'll forget it otherwise.
Okay, Troy, thank you very much for that. Pete, thank you for the question, as well as Rod. It always makes it a little bit more interactive. So, unless there are we at time?
There's 1 minute left, so I think we're
okay. Yeah, so I'm not going to ask for more questions. I am going to close it down. And thank you everyone for attending. Thank you very much, Troy, for presenting. And catch you all later on another session. Thanks all. Bye.
Thank you.